we're on operational over mathematical.
Okay. So what was the question? Oh, your question started out is everything is reducible to evolutionary computation. I would say the correct framework of understanding the world is as actions,
Yes.
evolutionary computation. In other words, what permutations are possible given the operations available to the universe at every scale of abstraction. In other words, every scale. So think of it as the universe can only form so many puzzle pieces at every, right? Because we know basically it can only form one. Right? And so the problem is once you increase the energy by combining triangles, you get combinations that can fit with other puzzle pieces, other combinations. But there are combinations you can't have, right? So there are two problems that arise here. One is that some of those combinations are predictable, which means it's mathematically reducible, right? And some of them are not. They're only
irrational, right?
They're only operationally constructible. In other words, they're unpredictable, and they're not mathematically reducible. So the field of things that's capable of being produced by operations is larger than the field of things that can be produced mathematically.
By prediction, right?
Right? Because why? All of mathematics is statistical. In other words, it's always the average of something, right?
This is funny to me because it's like this. It's like the patient goes like this. Here's how the patient presents. This is with some frequency, okay? But what's the average? I'm like, it doesn't matter. It has no meaning in this context. It's like we're talking about you, not averages.
There is no average.
Abstractions, right? That's interesting. I like that. So you're
so no, there's three. So realize there's a spectrum here. So there's the operationally impossible.
Yep.
There's the operationally possible.
Yep.
And of the operationally possible, there are some things that are mathematically reducible.
Some things.
Some things. In other words, think of it as sentences,
Yep.
right? I can tell you a general story.
Yep.
Which is what we mean by a theory.
Right.
A theory that's mathematically reducible, right? Or no, it's a law, excuse me. That's what we mean by law. I can reduce something to a mathematical number, but not all laws are mathematically reducible. They're still theories, but they're not reducible to laws. Are they laws? Absolutely. But the way we define law is mathematically reducible. So I'm saying that you can't conflate these two things anymore. Something is just mathematically reducible because it's a regularity independent scale. Something is not mathematically reducible, but it's operationally constructible. And some things that are not operationally constructible. And in the ideal world, there is some universe of maximally operationally constructible. One of the current questions, let's just give this as the example, is we tend to think of the periodic table as relatively closed, complete. But let's just hypothetically say there might be older stars that could produce greater variations in internal mass for something, that could cook more combinations of elements through more generations of stars. Is that possible? I don't know. I mean, it seems like not, but the idea makes sense, right?
We can't exclude the possibility.
We can't exclude the possibility that there isn't another alternative, right?
Right.
In other words, when we can't exclude the possibility that there's some, either the black hole or just massive old stars, right, that have gone, or what happened. Our star is what, a fourth generation star or something like that. I don't know.
Okay.
Right. So maybe at the 10th generation of stars, really large star, it's cooking some set of new elements that are even more complex.
Something.
It's unlikely, but
That's
right. So yes, when you start out with the question, is this evolutionary computation? The answer is yes. What do we mean by evolutionary computation? We mean that the universe uses recombinations to accumulate energy at different levels of complexity. At every level of complexity, there emerges a new set of operations, right? Possible, in other words, new combinations become possible at new scales. I mean, realistically, a protein is an incredibly complicated thing, right? I mean, the long strands of chemicals that basically do work. I mean, they're literally machines.
Machines, right? They do stuff.
They do stuff. That's why, it's like we are so much better in our world now that we have machines. But the protein is the equivalent of the Industrial Revolution for life.
Molecules, yeah.
Molecules, right?
Right.
So yeah, but if I say that, that's like going forward. But in order to get the concept across, why, or in other words, why is it evolutionary computation? You have to understand this problem of computational reducibility, or what is mathematics capable of, and what are operations capable of. Mathematics is capable of less than operations are capable of. Now, so the gold standard is not mathematics, it's operations.
Yeah.
Mathematics
is like this. I went to med school in Missouri, so show me. I don't want to hear about it. I love hanging out with you, Kurt. This is freaking good work.
So let me make two more, complete it. So now that we've got to why, right? We now know that what went wrong is what I bring up all the time, is that when Babbage got to the first computer, he didn't say, hey, by the way, we're doing this wrong.
And in addition, right?
Yes.
Oops.
And so
not to rail on Mr. Babbage.
It's not his fault. He was English.
He did his best. He did his best. Okay, sorry to interrupt you again.
It's a very English thing. I can just see that.
I appreciate it.
And so this reversal of the primacy of mathematics to the reversal of operationalism, from idealism, averages, and analogies in mathematics, which we falsely consider the gold standard.
Thank you.
Changing from that to operations. Well, why can we do that? Because we actually have enough knowledge now to express the world as operations, whereas we didn't have before. And so now we have enough knowledge about the world to understand it as basically electromagnetic, polarization and energy accumulation. It's just fucking, it's so stupidly simple, it's ridiculous. It really is. It's annoying that we spent thousands of years trying to figure out. No, it turns out it's really simple.